Hey everyone, today we are going to start reviewing some uncertainty, and we're going to start our unit diving into significant figures. What are they and why do we use those? We'll learn about the rules tomorrow, but today we want to focus on uncertainty. So anytime you take a measurement, there's always some level of uncertainty, and that's basically just what you have to estimate. Uncertainty and precision all depends on the device that you're using. So if you have a ruler that only measures centimeters, then you're only going to be able to estimate to the nearest millimeter, and there's still some uncertainty there because what we'll talk about here in a moment is mentally we can always divide a section into smaller pieces because we're used to working with fractions. We're used to being able to split things in half and say, well, it's kind of between these two numbers, and make an educated guess. And that's kind of what we're thinking about when we think about uncertainty. So I'm going to go through and do some examples with you here, and we're going to read through this, and then I'm going to write a few examples down for you, and then you will finish this worksheet out on your own today and submit those answers to Canvas. So let's just go ahead and go through this together. So first of all, significant figures are all of the digits that you know for sure plus one estimate or one uncertain digit. So uncertainty, like I said, it says it's the limit of precision of the reading. So it's your ability to estimate. And let's say we have a ruler here, and of course we can see that there's 10 marks between this 6 and 7, and we don't know what this is. 6 and 7 feet, is this 6 and 7 inches? We don't know, it's not given, but let's say we're looking at this, and let's call this centimeters, okay? So this is 1 full centimeter. And when you see something like this, every space can be divided like mentally into 10 smaller spaces. So here we know for certain that this is 6.1, 2, 3, 4, 5. We know there's 10 marks here, so we know that these are tenths. So 6.5, 6, 7, 8. We know for certain that that arrow is at least 6.8, and now I need to estimate one more digit. So I would say that this is 6.8, and now I can estimate the hundredths digit. So 6.8, it looks a little less than halfway between those two marks. So I would say like 6.84, and 4 would be my estimated or my uncertain digit in this example. Let's look at this one. And that's if we imagine 10 divisions. Okay, sometimes it might be easier to imagine 5 divisions or 2 divisions. And so in this case, if we were to imagine 5 divisions, we would say that that is 6.8 for certain. And then my uncertainty is going to be plus or minus 0.02. So I might say that's 6.84 plus or minus 0.02. It says that, I'm very confident that it's that number plus or minus my uncertain value. So if we divide it into tenths, then our uncertainty would be plus or minus 0.01 in this case, because we estimated that hundredths value, and we're pretty sure that we got it right within 1/100ths. If you divide it into 5 sections, then 2/100ths. Okay, and don't worry about this. Don't get boggled down. You'll see how easy it is in a moment. Normally, we naturally divide things into 10. Okay, so here if we were to divide into 2 sections, then we would say we know for certain it's 6.8, and then that arrow looks like it's at 6.85. Sometimes on a ruler it's so hard to tell that there's actually like a fraction amount there. So this would be 6.85. Right, and we don't really need to worry about the rules for the zeros just yet. We're going to talk about that tomorrow, but basically zeros are just placeholders. And again, you'll look at that again tomorrow in tomorrow's lesson. Basically, if you can write it in scientific notation, the zeros are what you take away from scientific notation. Those are not significant. They're not important to the value other than to say it's a factor of 10, really. So let's just look at some examples here, okay? I will do the odds here, and I'm going to leave you the evens to do on your own. So actually, let me pause this. All right, so I pulled the worksheet up on a different camera so I can write with you here. With each problem, we're going to write what we think the reading is and then how many significant digits there are. Remember, significant digits are the number we know for certain and then one estimated value. And we always have to have that estimate even if we think it's on zero. So let's look at this one. We know for certain that this number is 8 point something. Okay, now mentally I could divide this up into tenths, and I would say that this is 8.9 because that arrow is right under the 9 there. So that's 8.9, and that has 2 sig figs. So 8.9 here, and we could even say plus or minus a tenth space. That says that maybe that number is somewhere between 8.8 and 9. Okay, that's what that plus or minus 0.1 would be. It means we estimated the tenths place. Okay, let's look at number 3. So number 3, we know for certain that it's 120, 130, and I have to estimate the next digit. I know for certain 130. And it looks like it's between 130 and 140, but it's not quite 135. I'm going to call that 134. So here I estimated the ones place because if I were to divide this into 10 more sections, I don't know how many that is, but if I were to divide it into 10 more sections, then each one of those would represent one value. Okay, I estimated the ones place. And so that's 1, 2, 3 significant digits. Let's look at 1, 2, 3, 4, number 5 now. Okay, so here we know for certain it's 110, 11, 12, 13, 14. I know it's 114, and then I can divide that into 10 smaller sections. So I want to say that's 114.2. Okay, and so I estimated again the tenths space. So that would be, well, let's look back at this one. If I estimated the ones place, I could write plus or minus 1. It means I'm pretty confident it's either 133, 134, 135, something like that, somewhere in that range. Here, I could say plus or minus 0.1. That means it might be 114.1, or it could be all the way as high as 114.3. It's just a way to estimate our reading when we are measuring something. Okay, anytime you're measuring anything in your house with a measuring tape, you'll notice that you always have to make those mental divisions, and that's what we're looking for. So here we have 1, 2, 3, 4 significant digits. Okay. I wanted to let's look at number 8. I know that's an even problem, but I want to show you how it's a little different. So I know this is blurry. I'm sorry. My camera is not doing very well tonight. But here we have 0.01, 0.02. This right here would be 0.025. And this right here would be 0.026. Now I'm going to write what I know for certain. I know it's 0.026. Now this arrow looks like it is right on the line. Okay, so I still have to have that estimated digit. Okay, So 0.026, and because it's right on the line, I'm going to estimate that that is a 0. And here I estimated the thousandths place, no, the 10,000ths place. So that might be plus or minus 0.0001 there. Don't worry so much about this plus or minus part. I'm not really going to ask you that on a test. We just need to make sure that we can read this and use the proper uncertainty values, or, you know, estimate the right digit. So here we have, so leading zeros actually are not important. This would be like, if I were to put that in scientific notation, I don't care about that 0. It's just a placeholder. Now, on the flip side of that, I do care about this 0 because I estimated it. So it is a significant digit. Remember, the definition that we just said was all of the non-zero numbers in a measurement and one estimated digit. So in this case, there's 1, 2, 3 sig figs. All right, let's see what else is on this worksheet for you to do today. All right, so there's another, these scales are awful hard to read, but you will have them, and I'll do maybe 2 of these with you. So we're going to do the scale reading and then our uncertainty, okay? And again, I know this is hard to see. Let's look at this. So here we know for certain it's 150. Let's see what each of these are going up by. This is 175. So each of these little marks are going up by 5. So 5, 10, 15, 20, 25, and then this, well, that would be 75, 80, 85, 90, 95, 200. Okay? So in this case, we know it's 175. And then it looks like it's between 175 and 180. Ooh, sorry. 175 and 180. So we're going to go ahead and estimate. I would say it's 177, okay? And our uncertainty, like if I were to divide that up into even smaller chunks, my uncertainty might be plus or minus 1, okay? And let's do one more. Let's look at this one here. So I know for certain it's 100. This is 150. So I'm going to estimate that maybe that's around 130. And my uncertainty would be plus or minus 10. Because it could be 140, it could be 120, depending on how we read it. But we're pretty sure that it's somewhere in that range. Right. So today you're going to finish those 2 pages that we worked together and make sure you get those right answers. And of course, let me know if you have any questions. Again, today is just reading those measurements and making sure that we can identify the uncertain estimate, okay? And again, let me know if you need anything.